Hey, everyone out there in the live stream, thanks so much for being here. It's great to see you all. So many exciting comments here. Unexpected Maker, glad you're able to make it. Hello, Matt, Mike, Corey, thanks for the heads up on the talk. Hello, Johnny, Jim. Please keep the comments coming during the show. I'll try to send them along to Scott and Damien. And yeah, we'll go ahead and get started if you two are ready.
Yep.
Scott, Damien, welcome to Talk Python to me. Damien, welcome back. Scott, great to have you here.
Thanks for having me.
Hi. Yeah, thanks for having me as well.
Yeah, it's really good to have you both here. And normally I ask people how they got into programming. Damien, you've already told your story, and maybe I think we'll mix it up just a little bit. Let's maybe just have you both do a quick introduction about how you fit into the Python world and what you're up to these days. Damien, you want to go first?
Sure. So I'm the creator of MicroPython. It's been a long journey in the past 9 years or so. Before that, I was a theoretical physicist, and I studied at Melbourne University in Australia and did a PhD in theoretical physics. My PhD was in extra dimensions and kind of string theory related stuff.
Oh, that's super cool.
Yeah,
it can be like a astrophysics type thing. It's got to be something small if you're working on MicroPython, right? Like if that's your
well, the thing with particle physics is all about the tiny things. The quarks is sort of as small as we know, but also linking to cosmology, which is the really huge things. And the idea of cosmology is to link the tiny with the large. But yeah, it was that's all, I guess, very different from microcontrollers and programming and software and hardware and real tangible
How do you
things.
get from physics to programming side of things?
I always liked computers and programming, and I always sort of had that as a side hobby. And I actually also studied computer engineering and mathematics. But physics was the thing I kept, I did sort of professionally, if you could say that. And always had on the side, microcontrollers on my desk and CNC machines and sort of half-built robots. And so turned that eventually into MicroPython. And when I was doing my PhD, when I was doing a postdoc in Cambridge, and did a Kickstarter with MicroPython, and then that all sort of continued and grew, and that's how I sort of end up where I am now.
Cool. Kickstarter was so neat when it came out in 2015, 2014, whatever time that was. It seemed like it had such possibility. Now I don't hear about it as much anymore. I know it's still out there, but
yeah, I think it was a bit earlier than that, because we did it in the end of 2013, and it had already been around a few years. But it was such a huge thing back then.
Yeah, super cool that you launched it on that. Scott, how about you?
So I got into programming with PHP was my first language. So I came kind of like from the web side of things. And then when I wanted to do desktop apps, I found Python. And you can still find a SourceForge page for a program called Denu, which was like dynamic menu stuff for like managing your menus in Linux. That was my first Python program. That was 2004. So that's before I went to university. And then I got a computer engineering degree, and I taught some of the intro TA classes there and did like a Python version of it there. So like Python's kind of always followed me throughout my career. After university, I did 6 years in industry, and then took a year off and did drone flight controller hardware stuff. And then when that was like coming to an end, when I was gonna have to find a new job, I went to Adafruit and said like, hey, I need a job. And they were like, hey, we have this project in mind. Are you okay doing a project that we want? And it was to do bring MicroPython to their boards that had a different microcontroller than what MicroPython supported originally. So that was in August of 2016 that I started working on the Adafruit version of MicroPython, which then became CircuitPython. So CircuitPython is a fork of MicroPython that originally was for Adafruit's microcontrollers, and we've really pushed it to be really uniform and a good beginner experience. So that's kind of how we fit in.
Yeah, it's super
in
interesting.
brief.
Well, it sounds to me like with your drone experience and all the small servos and electronics and then this programming background, it's kind of a nice thing to bring together as well, right?
Yeah, I mean, I had done Python for a long time, and I had just gotten into embedded, and I really like that the software depth, so to speak, is like much thinner, right? Like there's a lot less software between the hardware and your code. And I thought that was really cool. And MicroPython was amazing how well it brings Python to those inexpensive devices.
Yeah. So MicroPython was first, Damien, and then CircuitPython was forked from it to, like Scott said, to make it work a little bit closer with the Adafruit stuff. Is that sort of the history of it there?
Yeah. I think there's sort of a different focus on the end user, and what level of experience you have, and kind of what you intend to do with the device. So I see it as MicroPython being used in industry and professionally to build products, and CircuitPython is to support, initially to support Adafruit's hardware, but also more for kind of beginners and people who are getting into hardware and want to have a sort of much easier onboarding with libraries and things that are working with the hardware that Adafruit provides. So there's a real distinction there with the audience, and therefore the kind of features and things that we focus on. So there's a lot of focus in MicroPython on code coverage and making sure things are really stable, or as stable as we can make them across releases, so that people who are working with MicroPython in a product can continue to work and it's and be confident that updating will fix bugs and not change other things too drastically. And we get a lot of sort of requests for features and bug fixes and things from people using it professionally. And so I have to keep an eye out sort of on a lot of all these things, so that when they come together, all the people I know who are using MicroPython are not going to suddenly be have the rug pulled out from under them when they switch to the next version because something else has changed.
All right, so that's an interesting distinction. The sort of pro production side versus Adafruit is so very welcoming towards, this is your first project, your first IoT thing. I like to build something for like a science project. I mean, Scott, maybe you could classify it better, certainly better than I do what the specific focus is. But when I go to Adafruit and I look around, I get this feel that it's very much like these kits and very supportive of like getting started, and not like, hey, how's your robot doing? Here's where you plug in the thing for your industrial car making robot.
Yeah, I mean, I think you're both right on it. I think there's a bit two aspects to it. One is like the focus that I brought to the project, and I mentioned the TAing the intro course in university, because I think that does have a lot of influence over how I drive our focus for CircuitPython. Is like, we're very focused on what that experience in the first 5 minutes that you've ever programmed, not just hardware, but programming in general, what that first 5 minute experience is. So we've done things like all of those CircuitPython boards that we now support are all show up as a USB drive once you've put CircuitPython on it. And so all of the tutorials and things that we've written on top of that is uniform across that. And then that dovetails nicely into Adafruit's business model, where they really do focus on beginners, because the reality is there's far more beginners than there are intermediate and advanced electronics folks. So from a business perspective, Adafruit's interested in the beginner side, just because that's where the vast majority of people are.
Yeah, I also feel like the zen or the ethos of Adafruit at the beginning was to inspire people getting into programming and getting into hardware, like from the beginning, right? That was sort of almost why it was founded.
Yeah, I mean, like Adafruit started around, like, it's always been a matter of open source software, open source hardware, and open source tutorials, right? Like Limor, the founder of Adafruit, who goes by Lady Ada, like she started, even before Adafruit was a company, writing tutorials about how people could go get all the parts to build this one thing. So that's very, a lot of what we think about with CircuitPython is not necessarily teaching you to code from if statements and for loops, but actually just getting you all the code to do a project. And then from there, now it's modifying that project in the way that you want rather than starting from a blank screen.
Yeah, very cool. Coming out in the live stream, Sean Tibor from Teaching Python podcast. Hey, Sean. He's a teacher who teaches programming. Also, I know uses some of the Adafruit stuff and CircuitPython. It says the speed from 0 to blinky lights is really important for learning. We've got that study from the BBC Microbit where they gave that to, I guess, all 7th graders or something in the UK. I think that's roughly right anyway. And it really changed how many people saw themselves as interested in programming, especially like young girls said, well, they're way more likely to take a programming course after having something physical and neat that you can play with rather than just a terminal with a print statement. So yeah, I think that I agree with that as well. What do y'all think?
Yeah, I agree. Getting a blinking light it's the hello world of microcontrollers, but it's actually really quite hard. Whatever your piece of hardware is. So often when I'm making MicroPython work on a new piece of hardware, the thing you can get to is once you can get a blinking LED, then you're sort of set. But getting there is really hard. And I'm not talking actually about blinking an LED in Python. I'm just, blinking LED however you can in assembly or C or whatever. Because, getting a tool chain working, making this, plugging in the board, powering it up, knowing how to power it up, knowing how to get it into a mode where you can change the firmware on it. These things can take days. I mean, or longer. And
why is my serial port working right? And, all sorts of stuff. Yeah.
So to port MicroPython to a new microcontroller, once you've got a tool chain, a way to flash the device, and you can blink an LED or write characters to a UART, then getting MicroPython working is probably another hour's worth of work. It's and then you've got the whole of MicroPython ecosystem that you can play with. But from a beginner's point of view, it's a similar sort of story. When they get something, they've never done it before, they've got a piece of hardware and what's going on. So blinking an LED, to get to that stage, there's a lot of kind of conceptual hurdles and also, maybe installing things on your computer hurdles as well. But to get to a blinking LED is really the beginning, and then from there you can be a whole sort of world of possibility opens up because you can see then how you can turn that into a real life project. Yeah,
start to work with the other sensors, things like the accelerometers or motion or microphone or anything, right?
Exactly. Yep.
Yeah, I think maybe it makes sense to pause for just a moment and define microcontroller for people. So I have a Mac Mini here. It's small, right? That's not a microcontroller. I could get a Raspberry Pi, which is even smaller, still not a microcontroller. Like, give us a sense for the size of these boards and like, what does the hardware look like?
I mean, it's not really physical size. A microcontroller itself is actually more complicated than a PC in some sense. That a PC like a Mac Mini or a laptop or a Raspberry Pi, that has a CPU in it, and it's connected usually to a keyboard and a screen and maybe some audio and Wi-Fi or some kind of internet. And it's relatively straightforward. It's a CPU that is fast and does a lot of processing, and can output to a screen at a high refresh rate, and you can interact with it. But a microcontroller is a CPU plus a lot of other peripherals around it, like UART and SPI and I2C and I2S and Ethernet and Wi-Fi, and then really low-level stuff like DMA and things that make the microcontroller work in a microcontroller way, timers that interrupt it very precisely. So a microcontroller is what they say sometimes a system on a chip, SoC. It's a real tightly interconnected piece of silicon which has a CPU at the center which controls things, but what's more important is the things it's controlling. And it's got to do that in a really precise and real-time way, so that what it's controlling, say a coffee machine or an airplane, is guaranteed to work every time the same way and run for years without having any problems. But if you have a laptop, and that's probably not going to run for years without needing to be upgraded, or crashing for some reason, or
it's odd how that works, right? Yeah.
So yeah, there is this kind of distinction there. It's a bit subtle, but the microcontroller is a really precise machine and a really complex machine in the way it interacts.
Would you say more real time?
Yes, that's one of its tasks, is to be real time. And it's not as powerful as a laptop or a PC, but it is more sort of capable. And also programming it is a lot harder.
So I think it's important to say that like microcontrollers are typically used to do a single task in a larger system. So think of your car, and like I think a Tesla has like a microcontroller that manages the door handle, for example. Okay. So microcontrollers are in a lot of things. Damien said toasters, and another example. So that means that they're everywhere. You just don't see them. And that has the benefit of being very low cost. So the microcontrollers, which are like the black chip on the circuit playground you see here, they're only like a couple centimeters square. They'll cost under $1 or a few dollars at most, which means that they're really inexpensive to get into. In terms of processing power, what you'll see is like if my desktop has 32 gigs of RAM, right? But a microcontroller will have anywhere from like 8 kilobytes of RAM up to maybe a megabyte of RAM, or a few megabytes of RAM at the higher end. And the distinction between like a microcontroller and a microprocessor also involves like how good it is at doing multiple things. Specifically, like there's memory protection stuff that will happen in your like desktop CPU that a microcontroller typically cannot do. So really, it's usually just a single task thing.
So unlike Mac OS or Linux or whatever, you've got the OS, and then it's running your processes often in user space. They have protected memory. There's a bunch of them. The OS is doing preemptive multi-threading, all those kinds of things. Your Python program, your MicroPython or CircuitPython basically is the operating system almost, right? It's like got full control.
Right. In some cases, there's a real-time operating system under the hood, but in some other cases, there isn't.
Okay. Interesting. So one of the things that might be fun to talk about is we've got MicroPython and we've got CircuitPython, and we've also, when people say Python, they often mean python.org, CPython, Python. Damien, you want to start us off with maybe like what's the difference between this huge, I don't know how large it is, 40, 50 megabyte thing I download from python.org, and then maybe what MicroPython is? What's the same and what's different? Could I take a random Python program and run it on MicroPython and so on?
Yeah, that's a really good question. And I guess, it's sort of the biggest thing about if it's called Python, like MicroPython, shouldn't it be just the same as Python? And why can't I just use Python instead if it's the same?
Yeah.
So to begin with, you can't run Python on a little microcontroller because Python uses too much memory. Is kind of the reason.
Just to load the runtime libraries probably exceeds the entire working memory of these tips, right? I mean,
just to load sort of the mapping table of Unicode character names is megabytes of data, which MicroPython obviously doesn't support. But so one of the main things when I was writing MicroPython was to make sure it didn't use memory where possible. So all of the things that could be put into read-only memory or flash or ROM were put in there. So dictionaries and modules and things that are sort of built in, like a sys module, all of that is in read-only memory in MicroPython and CircuitPython, whereas in normal Python, pretty much everything is put into RAM. And so when you make, if you tried to run Python on a CPython on a microcontroller, you would need megabytes of RAM. And that really is the main difference. But then there's a lot of other, things on a sort of a list of things that are different to make MicroPython efficient on a microcontroller. To make it small in code size, to make it run relatively efficiently. And as part of that, we had to make some sacrifices in compatibility with CPython. So there are some things that are not the same. But for the most part, MicroPython and CircuitPython really do feel like normal Python. The syntax is the same, at least up to a given Python version, because Python keeps adding syntax. The syntax is exactly the same, and the semantics of the syntax are the same. And a lot of the built-in types are, will have a one-to-one mapping with the same semantics and the same methods. So there's a lot of things down there that are very, very similar, because Python is such a dynamic language and such a big language that it has so many sort of little corner cases and things that are, behave a certain way. And when you're used to Python, you're used to the
I want to change that
way.
meta class so that this other thing does this other weird thing in this way. And I'm expecting to patch that when we load this module. And
yeah, yeah, exactly.
Scott shaking his head like, maybe not.
But even down to things like how division and modulo work with negative numbers is sort of very specific. When you have A modulo B and the negative numbers, then the answer is a certain way. And MicroPython copies that as well. So there's a lot of subtleties there that you may not realize, that over the years we've gotten to make sure it's the same as CPython, just because we've got a lot of tests and a lot of people giving feedback when it's not exactly as they expect.
Yeah.
I've definitely learned so much about CPython and, the Python language, because so many things I had no idea about.
You had to get the exact nuanced details of how this thing or that thing works, right? To make sure it's the same. One of the things that I think is worth keeping in mind as people think about this is when somebody says, I love Python, or I think Python works this way, or Python is this thing and it's productive, or it's whatever, it's slow, it's fast. They often can be talking about many things. Somebody could say, I love Python, and they mean the Python syntax. Somebody could say, I love Python, they're like, the standard library is so cool that it comes with all these things in the standard library. They could mean I pip installed pandas and requests, and now something cool happened, right? Yeah. When you say Python runs there, there's like, you kind of got to say, okay, well, what are we talking about, right? It's mostly the language for sure, but there's got to be a ton of standard library things that don't make sense. Like there's this one about parsing CSS hex values, like who cares? tk-enter, don't care.
Yeah, I did.
SQLite, maybe? I don't know.
Yeah.
I was gonna say I did actually do a lightning talk at the last language summit, kind of on this topic, and like Damien was saying, to his credit, MicroPython is Python in the core syntax areas and the built-in types. But as you kind of grow outwards into the standard library, things get omitted a lot, because frankly the standard library in CPython is large. And so I did kind of a comparison there, and I can share people with the slides, but take all this stuff in CPython and show what's in CircuitPython. And
that's cool.
I've been having discussions off and on with Brett Cannon about this as well, because he's been thinking about how would you define a minimum version of Python? And I think that MicroPython did such a great job of that. It feels like Python to me. I had the background in Python before, so coming to MicroPython, it felt very natural. So I think we're a good case for that.
Yeah, I think you definitely are. Brett I know he's been thinking a lot about WebAssembly and what would it look like if we could have Python in WebAssembly, and we could have it in these other, what would a mobile Python look like, and these different environments that are not just desktops plus servers, and having this standard core Python subset is a pretty neat idea. Yeah. A couple of things from the live stream. Sean has a warning for everyone who gets into this that these microcontrollers tend to multiply quickly. He started with just one or two. Now he has a whole collection. I can't see what's in your background, Damien, but Scott, you seem to have a bunch of these things gathered around.
Oh yeah, this room is a mess right now. I probably have at least a dozen on my desk though as well.
Yeah, I just got to find new and inventive ways of actually organizing them. Because I mean, there's things like a box full of dev boards, sort of in plastic blister packs.
Yeah, I take them out of them.
Just sitting there.
The blister packs are too big. I try to take those out.
Yeah.
Oh
I have
my gosh.
bins per manufacturer, so like STM, NRF, Atmel, of all the different development boards.
Yeah.
Yeah.
I don't know. There's a whole lot of stuff everywhere. Like just.
They're inexpensive. They're impulse buyable, which is bad.
Exactly. I'll take 3 of those and one of these, and yeah, amazing. But it's got to be a collection of cool little things.
Yeah, it's also important to figure out like what each individual microcontroller can do uniquely. What makes something unique? Like it's obvious. Like if it's a BLE chip, then that's obviously what you want to do. If it's Wi-Fi, that's what it can do. But the RP2040, which is the new chip from Raspberry Pi, like they have this really weird, unique peripheral that allows to do really, really, really real-time stuff. Because an actual CPU and a microcontroller is still not perfectly real-time. So they have this like special thing that they added that can do some really impressive real-time stuff. So it's very interesting to see like the stuff that's standard between all these things and then what's different.
Yeah, I can imagine. All right. Well, one more interesting thing I want to ask you about from the live stream. Tim out there asks, what are your thoughts on CircuitPython being used in TI calculators? So the new TI-84 comes with programming and you can write Python. There's this bit in here.
Mm-hmm.
I don't remember here it is, the programming bits where you can see. But yeah, I mean, I remember programming in calculators being...
Yeah, I did that.
Really weird. Yeah, I did too. I mean, a little bit funky, but having Python there is quite neat as well. And
yeah, so this is a fork of CircuitPython.
Interesting.
So it's not publicly released, which is totally okay. And they are careful not to call it CircuitPython, which is good as well. But that does mean that like if you go to circuitpython.org/downloads, you won't find like the latest version of CircuitPython for your calculator. But generally, I think it's great. Like I love seeing people build on CircuitPython just like we've built on MicroPython. Like people should do that. It's really neat.
Yeah, absolutely. And then another one out there that's neat that says, Matt says, MicroPython and the new Lego Spike delighted the inner teenager in me. Did you catch that, Damien? Did you?
Yes.
You must have known about this, right?
Yes.
How do you take this news?
Yeah, that was pretty amazing. It was a year or a couple of years ago, I think, or maybe even longer, 3 years.
Yeah, a little while.
When they started, they contacted me about it. So it's still an ongoing thing. You can, there's the Lego Education, which is separate to sort of Lego Retail. Lego Education is for schools. I remember using that when I was in high school a long, long time ago. It's obviously Lego, but it's the different kit and it's different focus on what you do with it. And the Lego Education these days, sort of the new version of Mindstorms, uses MicroPython in the hub, the sort of the central processing unit, the central sort of Lego control block.
Do they expose that to the kids to play with, or is it just like a runtime internal sort of thing?
It's kind of both. The thing that you can get for Lego Education is using MicroPython to implement sort of what the kids see. But I think there are plans to make it so that you can actually use MicroPython directly.
That'd be really neat.
Yeah. So
right,
yeah,
Scott,
very cool.
Yeah, very cool news. I think it's great. Scott, I asked about the comparison between MicroPython and CPython. You want to close the circle and go from maybe the differences of MicroPython and CircuitPython? Like, why are there two things here and whatnot?
I think that,
help people think about, like, if I'm going to work with one or the other, where would they go?
yeah, so I think the why is what Damon iterated earlier, is like our focus in CircuitPython really is beginners. And coming into Adafruit, I also knew that their model is that, like, for every device that they sell, they provide example code and drivers for it. And because Adafruit was going to do this for the Python world, we had to make sure that the hardware abstraction layer, like the modules you import in Python that allow you access to the hardware, would be consistent across everything that runs CircuitPython. So you saw me get like a little niggly about, like, it's not actually CircuitPython on the TI calculator, because like I think the branding of CircuitPython is really important, because it means that you can download it from the website, you can use the APIs that we have standard as CircuitPython, and therefore all of our CircuitPython libraries work on top of that. All our guides for CircuitPython work on top of that.
Yeah.
So that was really, one of the more important things for us, is having that uniform API that we can then build all of this Python software on top of. So that's one of the main differences. I should say that we do actually have this layer called Blinka now, that allows you to use MicroPython under the hood, or actually CPython under the hood. But it presents that same CircuitPython API for other things as well. So this line has been blurred some.
Right.
But the thing that doesn't come with that is that in CircuitPython, we still do ensure that your kind of workflow is the same as well. So all of the CircuitPython boards that you can download now, except in the future, this is going to change, show up as a CircuitPy drive, and you can edit the code.py file on it. It runs after you save it automatically. And it's really quick and easy to iterate on. So I would encourage...
So basically, there's a file watcher that looks at your source file that is the program, and if it sees it changes, it kind of just reboots super quick and reruns it, right?
It's not even that smart. It's any write to the file system. It doesn't know what file you're writing to. It's just any write will trigger that. And the caveat I had is I'm working on a BLE only workflow as well. So in the future, there will be two ways of using CircuitPython. There will be a USB way and a Bluetooth low energy way, because
so you don't have to actually connect physically to the thing. It could be over there and you could program it.
That, and from phones and tablets in particular, devices that aren't really easily interoperable over USB. We want to bring the beginner experience of programming in CircuitPython to those devices as well. So that's the caveat. Like right now, everything does USB, but I'm like working on the Microbit V2 right now that will not be doing USB. It'll only be doing Bluetooth low energy.
Yeah, that sounds more complicated.
Yeah,
but also very useful. But I just, without a wire,
Yeah,
I'm just thinking of when my headphones like get disconnected. I'm like, oh, interference, how frustrating. But when that's your connection, right?
Bluetooth's come a long way, and I have had it working a bit. A lot of the challenge with Bluetooth is there's no standard way of doing like file transfer. So we really we're working on apps to be able to transfer files, and apps that are letting you will pull down all the example code and automatically load that over. And that file transfer API that we have is all public. So if folks want a link to that, I can send them a link to that protocol. So there's a lot more work off the device to do for this Bluetooth stuff.
That's cool. So I see on circuitpython.org, it says Blinka and CircuitPython libraries are just a pip install away. Mm-hmm. So if I'm working, but I'm on my desktop machine or server machine, can I still do like prototyping and try the libraries? What does that mean?
It's not every computer. If you're on a Raspberry Pi, it will work because that is supported. I think if you click that single board computers link, it'll show you all the ones that we specifically support. But single board computer is like a Linux class computer that usually breaks out general purpose IO, GPIO. So that's kind of the class of Linux computers that you'll be able to use this on.
Okay.
And then we do also have a couple cases where you could like plug something into your USB that would also like give you that GPIO on another device.
Yeah. Okay, cool. Question up from the live stream from Tim again. How has the workflow changed over the past, hold on a second. There we go. Sorry. How has the workflow changed over the past few years for CircuitPython and MicroPython when deploying code? And it sounds like Matt's talking about MP remote. Damien, you want to talk about what the deployment looks like?
There's a lot of sort of answers to that question from a MicroPython point of view. As I mentioned, if you're using MicroPython in a product, then it's a really different setup as if you're using it in a hobby, trying to make your light turn on and off. So using it in a professional setting, you'll probably have a big sort of workflow or setup where you can freeze the code into MicroPython and deploy it, or something like this.
Production, what do you put actually on there? Would you go and say, well, we're going to put a PYC file there instead of the Python file, or is there stuff like that you might do?
Yeah, it's not. We have MPY is sort of instead of PYC, precompiled code. Yes, but there's sort of a further step where you can take precompiled code and then sort of freeze that into a C data structure, which becomes part of the firmware itself. So big projects might have hundreds of Python files, which are then all precompiled and then frozen and then built into the firmware and then deployed onto the device.
Is there any room for something like Cython or Numba or one of these C compiler type things?
Yeah, Cython don't really support that, but you can write C code as well if you need to, if you really need speed. You can implement a module in C and then tie that into Python quite easily. So there are lots of options in terms of making things faster or efficient, or the way you do your workflow. But sort of to get back to the original question, so MP Remote is a new tool that was released in the last version, and it's intended to make a workflow, give you more options. You can use it to copy files on and off, get a REPL on the board, or one of the main features is to mount. So make your PC's file system available on the device that you're running on. So you mount your PC's file system on your Pi board or ESP32 or whatever. And then when you go onto the board and do a os.lister, you actually can list the files on your PC running on the board. So this allows you to basically do all your work on the PC, and then your board can import and run code from the PC, read and write files from the PC. And so the workflow is very quick. And when you're sort of happy, you can then precompile or copy files, MPY files onto the board to run it disconnected from the PC.
Yeah.
This is also good for sort of testing, integration tests of devices. They can sort of interact more closely with the PC that they're testing against. And just aims to provide you with more tools at your fingertips to make your workflow more productive.
Yeah, it's neat. When I want to put something onto my server to upgrade, like course site, something like that, I'll do some work locally. I'll do a git push. Some magic will happen. GitHub will do a webhook back over to the server. The server will grab that. It'll pull it down, install the new dependencies, restart the server through like a zero downtime sort of firewall type of thing. If I have a robot in a factory, what do I do? Is there a continuous deployment equivalent for MicroPython things, or what's the story look like over there?
Yeah, that's a good question. We don't.
I think this came up the last time we had a couple chats between like the folks that work on CircuitPython and the folks that work on MicroPython. And I think this was kind of a topic that we all said like, yeah, that would be really nice.
I mean, we don't have a sort of recommended or official way to do all of that. But I guess what you're talking about is over-the-air updates, maybe, kind of answers your question.
Basically, yeah. Like if I had a Tesla, sometimes I wake up in the morning, maybe my Tesla does different things. It's something like that, but for MicroPython things.
Well, if you have a factory full of robots, you probably don't want them to automatically update, because you need to be there when it happens, and you need to control it and do it at the right time and so on.
Yeah.
It really depends heavily on the project that you have, but over-the-air updates are sort of definitely the way to do this, and they have been done, and they are sort of out in the field, and they're done in lots of different ways. Like some over Bluetooth, where you download the new firmware and then
so a little like
on
what Scott's working on now.
Yeah. Sort of an automated way to install the new code and then reboot. And then other places where they're connected by a USB and you can just do a normal DFU upgrade or similar, or maybe over I2C they're listening in a special mode to download new code. There are lots of ways to do it, and there are lots of sort of parts in MicroPython's code that allow you to do it, and it really depends on your project. I think Scott has a different answer.
Well, I was going to say from the hobby side, like it's never, we don't focus on the automated update story. But, a lot of the folks that use CircuitPython are coming from an Arduino world. So Arduino is a really common hobby. It's based on C, but it's got some like stuff on top of the C stuff. But it means that you have to like have a computer that has Arduino installed that can compile the source code. And because we focus so much on this interaction of like it shows up as a USB drive, it actually means that it makes it more accessible to update. So if I'm remote and somebody wrote the software for me once, but now they want me to update it, like even though I don't understand how it's doing, I can plug it in, it shows up as a drive, and I can copy files over. It's really has been beneficial for folks that way, whether it's the Python code they're updating, or a lot of our boards also come with a bootloader, which is like the software that manages what you're installing. And a lot of our bootloaders for devices also show up as a drive as well. So it's still a manual process, but it's a manual process that's gotten better from the previous things.
Right. And from the hobby perspective, you could have a little app or something that says, oh, I noticed we're connected to this thing and it's out of date, so we're just going to push some stuff to it.
Yeah, we actually have some community members who've really fleshed out this app called Circup, CIRCUP, which you can pip install, and that will like figure out all the libraries on your CircuitPy drive that are out of date and update them for you. Which is pretty neat. So it's kind of like the pip of CircuitPython.
Yeah,
that's cool.
Yeah, that's very neat. Yeah, I'm just sure the requirements and concerns are extremely different if you're working with a small hobby device versus something that is controlling a robot or runs a thing that shouldn't go down. So one thing I wanted to definitely focus on while we were here together, seeing I find it is somewhere. Oh, it's hiding now. There's a lot of work that has been done. It sounds to me like on the CircuitPython side to catch up with MicroPython. Is that right? You want to tell us about that, Scott?
Yeah. So the history of this is like when Adafruit started paying me to work on what became CircuitPython, it was like, okay, I'm going to write a whole lot of code, right? So that's when on GitHub I hit fork. That's when I add a new port for Atmel SAMD, and that's kind of when we split. And later on, we decided like, we have enough changes here that it would be a lot of work for both Damien and us to get those changes merged back together. And that's still very true. But what I said at the time was that we would kind of keep pace for every stable release that we do. We would keep pace with stable releases from MicroPython. That wasn't true for about like 2 or 3 years. We stopped updating. It's basically a Git merge, right? So it's a whole lot of work. And so I did, we had 6 versions of MicroPython to merge in. So I did those. That's like 112 through 115 or 110, something like that. And then since then, we've actually updated 116 as well. So what's involved with that is like MicroPython has both like a Py folder, which you can think of as kind of like the VM. We think of that as kind of the core. And then there's separate ports for each main type of chip that we support. And we don't really share code with MicroPython for those different implementations for different chips. But we do share that core Python VM. So a lot of the work to merge in MicroPython is like updating all of that core stuff. And the discussions that Damien and I have had along with the other folks that work on these 2 projects has been like, all right, like what can we do just to get back to this world where we have the same copy of that Pi folder? Because there's like a few weird things that like CircuitPython has done that haven't been merged back into MicroPython, and we've had discussions about which things those are interesting, and which ones would we want to make configurable and things like that.
Yeah, interesting.
So now that we're updated, we have this foundation where we can have this discussion again, because we actually can tell like what the differences are between the two latest versions of these projects.
Yeah, Larry Bank out the live stream says, my imaging codecs still haven't been merged into MicroPython.
There's a lot of things that haven't been merged into MicroPython.
Yeah, Damien, I was going to ask you, what does this mean for MicroPython? Like, obviously, it makes sense for CircuitPython to just not be out of date. And, the farther you are away from one of these merges, it's more like credit card debt. And a little bit is fine, but as it gets farther, it starts to become a problem. But in reverse, there's probably a lot of things that people who are engaged on the CircuitPython side could bring back if it was basically the same.
Yeah, I mean, there are some, there's some great things that CircuitPython Scott has done with garbage collection, for one thing. And it's, it would be great to share a common PY folder at least. And as he said, we've had discussions about sort of how we can smooth things or make things more common, and where we know we differ, how we can make it easier that we differ. There have been recently actually a really good improvement in MicroPython for tab completion, so that it didn't tab complete underscore, and also tab completed imports. You do import space tab, and then it lists the tab completes the things you can import. And some good improvements for sort of fuzzing and sanitization of addresses, and sort of very subtle bug fixes that have come across. So it's really great to have an open source project, and because other people find bugs for you and fix them. So I think the more we can be in line, the better. And there are actually there are other people using MicroPython and CircuitPython, as we saw with the calculator and
Lego.
And I think in the early days, I was happy people were using MicroPython and wasn't too concerned about sort of people forking and changing things. But these days, I've shifted more towards, what can MicroPython do to make it easier for other people to use it without changing it?
Right. So when they're about to think, maybe I need to fork this to do this, you're like, well, why are they about to push that button? What can we do to make it more extensible, or whatever it needs to be, right?
Yeah. How can we make someone else's life easier so they don't have to fork? Not that we want to accommodate everybody, or we can't, but does it make sense to talk with these people and then make sure that their needs can be met in a sensible way, and maybe it helps everyone else as well. So it helps the community when you have less sort of forking and more cohesion.
Yeah, it absolutely does. I mean, we've seen the Python 2, Python 3 stuff mostly get resolved by people finally moving all onto the same place where the core devs spend their time. And I think it's only been beneficial. It seems like a lot of projects are taking some of these ideas and picking up speed, whereas there used to be a lot of hesitancy as there's like too many different paths in the road. Yeah.
Well, I'm just glad I did Python 3 from the beginning with MicroPython.
I bet you are.
I was just playing around with this. I was able to use like a smiley face emoji as a variable name, and it just worked, which kind of blew my mind. So that's a super credit to Damien for making MicroPython really, really strong, really robust, and really Python.
Yeah.
I think, in terms of like CircuitPython and MicroPython, another thing that I think we can really complement MicroPython with is like we're willing to be more experimental. Damien alluded to this memory allocation thing that I pitched to him at one point, and he was like, I was like, well, we'll put it in CircuitPython, we'll see how it goes, and then you can decide whether you want it or not. So I think that's a benefit that we can have in CircuitPython, is that like, because Damien really wants MicroPython to be stable, we can try things out in CircuitPython, and then he can pick the things that he wants to move into MicroPython.
That's a fantastic way to look at it. And the fact that you've got these merge differences, or these version differences down to such a small gap. It's not like, well, that would have worked 3 years ago, but I'm not sure it works now. Right? Now you're basically experimenting on what is the real thing.
Right. Yeah, and that's helpful for like this tab complete thing where like somebody added it into CircuitPython and we merged it, but then they also made a pull request to MicroPython, and like making sure that they're starting from a closer baseline will help everybody as well.
Yeah. And I mean, it's really good to hear you do 1.16, and we're trying hard from MicroPython side to release every 2 months or so that it's easier for everybody to upgrade, and it doesn't take so long for a new release to come out.
Mm-hmm.
Yeah. What's the schedule for CircuitPython, Scott?
We don't have a set timeline. We do try to get in a rhythm of doing. We do both stable and pre-release releases, and we don't have kind of a fixed schedule, but we tend to try to have like pretty recent pre-releases out, and then if it's been long enough that we're recommending the pre-release over the stable release, we ask ourselves like, okay, why aren't we just calling this a stable release? And
right.
that gives us a forcing function to up the stable release. We are kind of in this window between major releases, so we're currently like doing 7.0 stable or pre-releases for that, and that's a chance when we did all these merges. Because we get a lot of instability, not because the code we're merging in is bad, but the merge is really hard. It's hard to get correct. So we're kind of in this like very big state of flux right now with CircuitPython, where a lot of things are changing, and we're very quickly approaching this like, all right, we got to stop changing things so that we can stabilize, because we're no longer recommending the stable release. We're recommending the pre-release.
Yeah.
Because like when somebody introduces a new board and it's like, oh, well, that new board is not supported in the stable release, you have to use the pre-release. Like that's largely a forcing function for us.
Interesting that the hardware is driving the software like that.
Yeah, and that's a thing from like a number of us are funded by Adafruit to work on it. So when Adafruit releases new hardware, we have to decide like how we're going to make it available.
Absolutely. All right, let me take one question from the live stream. This is from Murray. Hey, Murray. I don't actually know the details, but I'll read it to you. I'm sure you all do. Here's a different question. What's the state of MicroPython-lib project as regards to the bigger MicroPython project?
Yes, that's a good question. The aim is to switch to improving MicroPython-lib. It languished a bit because well, there was just a lot of stuff to do in the main repository. But now that a lot of the code in the main repository has sort of stabilized and settled down and matured, there's more scope now to go and write everything. Well, write all the extra bits in Python and put them in MicroPython-lib. So we have recently reorganized that repository to be a bit clearer as to what's in there. And the aim is to maintain it and keep it running and put lots of libraries in there, improve the CPython standard library support, and other things. There, you might have noticed there was AIOBLE, which is a asynchronous Bluetooth library, which is in MicroPython-lib and is being used in production. It's pretty good in terms of stability. It's very good in terms of features and what it can do. It's really quite amazing how it makes Bluetooth simple. Bluetooth is a very asynchronous thing and a very high latency thing. So having an asynchronous API is really beneficial. So that's just one example of a library that is written in Python, pure Python, and is in MicroPython-lib. And we aim to continue that trend. I know that it's a little bit stale, some code in there, but we will fix things in the very near future.
Yeah. Very neat. Speaking of asynchronous, what are some of the, this question to both of you, what are some of the shiny language features that are new and neat in there, like async and await? Could I do that with the Bluetooth library? Or Walrus? Can I do a Walrus operator? What's going on?
Yep.
Like, what can I do?
Yep. Well, we have async. We have micro async IO, uasync IO, which is in its third sort of iteration, third version, and that's been, I think, about a year old now. That version, and that also has been used in quite a few production systems. That's also quite stable, and I think is a really good showcase of using Python on microcontrollers, because things on microcontrollers, well, some things take time, like reading a sensor and or waiting for a Bluetooth packet to arrive. And you've got to do lots of things at once, like blink a light to indicate progress.
It'd be great to be able, as those events come in, right?
Yeah, so event-based, but also easy to sort of use, because I mean, multi-threading, using threading in Python, you can do that on some MicroPython ports, but it's heavy weight in the sense that it uses a lot of memory for each stack, a stack of each thread, and it's slow to switch and respond. So it's not a great solution. So cooperative multitasking, which is what async IO is I think a better solution than threading on a microcontroller and even on a desktop. And it works really well. When you have something that's well suited to async IO, it's a really fun experience to program something.
And it's aptly named, because what it's really well suited to is waiting on things like IO, right? Waiting on these devices, on these various sensors and stuff to come back and just say, hey, I've got an input, or I've got a callback or whatever, right? Like it seems like the perfect case. It's not like, well, we're trying to do all this computational stuff asynchronous. Like, well, it doesn't work as quite well that way.
Yeah, like, you may just want to wait for a pin to change from high to low. So you spawn a task and you await on the pin, and then when that statement continues, it means the pin has changed. That's hard to do in a sort of callback based system. Well, it's not. I mean, it's just different conceptually, and maybe it's harder to reason about things. Yeah. So we have support for these fancy features, async IO, and the Walrus operator we had in. F strings are not yet in. I think CircuitPython has F strings.
Oh, you guys already have the F strings.
Yeah, Damien has a higher bar for merging than we do.
Interesting.
Yeah. So on CircuitPython side, we have F strings merged in, but we haven't done this work on the async stuff that Damien's really done. Because our audience is beginners, I really pushed us not to do async stuff. Because I think something that beginners don't necessarily understand is, like, the computer literally does things in order that you want it to do. So a lot of the examples that we use and that we get to people to doing just doesn't use async. So it's not been a focus of ours. One of the reasons to merge was to get the newer async stuff in and kind of hope that somebody would come along and turn it on and make sure it's all working. But kind of we've had the opposite approach. And I think, talking about async, one of the things that we've been thinking about is, like, async is very networking oriented in terms of Python, and it's not necessarily clear how that impacts hardware APIs and, like, waiting for pins and things. So I think it's really interesting to think about how async await applies to things like SPI transactions and I2C transactions, and what exactly I talked about how CircuitPython has a different hardware layer than MicroPython does, and, like, I don't think either of us have really come up with what does that look like when you have async await support. So I'm curious to see what Damien comes up with.
Yeah, I mean, we do. We have recently merged I2S support, which has preliminary async IO support in it as well. So you can, asynchronously send and receive audio buffers. We also have async support for pins using, well, a small sort of piece of wrapper code. A thread safe flag is our main sort of interaction between interrupts and async IO. So you create a thread slave flag object. On the async IO side, you wait on the flag, and on the IRQ side, so some event happens, like a SPI transaction completes, and you get an IRQ, and then you can set the thread safe flag, and then that will mean that the task waiting on that can continue. So yeah, but I agree, Scott, that it's still early days with the API for connecting I2C and things like that into the async world. I know one project I'm sort of working on uses async IO and Bluetooth and thread safe flag with pins, but yeah, nothing else is async. But the things that are async are very important to be async. And a lot of the time, just async IO.sleep is the thing you want. And yeah, just wait for a bit of time. So yeah, waiting on a pin and sleeping is actually gets you a long way. But I think it's still early days, and even async IO in CPython is sort of still early days in the sense that they're still trying to work through what API is good for streams, and there's Trio as well, which is providing good feedback to CPython on async IO. So it's still early days in the whole sort of Python space.
Yeah, there's my favorite unsync, which is a unification layer on tops of threads, multiprocessing, and async IO. And it's like, I think the whole implementation is 126 lines of Python in one file, but it's glorious. All right, one final topic I want to touch on here. There's been a lot of interesting work about making Python regular old server side, desktop side, CPython faster. There's been a bunch of interesting things coming on. Pigeon from Microsoft is kind of making a comeback. I think Anthony Shaw's doing some work on that. Maybe Brett Cannon as well. There's Cinder. The Instagram crew has released with really interesting stuff going on about making a lot of interesting changes in the runtime about making it faster. Stuff about like immortal instances that are sort of not subject to GC and reference counting and whatnot. We've got the latest language summit. Guido is talking about interesting things he's doing and focusing on to try to sort of accomplish the same goal. Like, is any of this stuff influencing what you all are thinking about, or is it just not really applicable?
I think, yeah, this is a really big topic because Python has a long history. And it's used in a lot of places for a lot of different things, and it's built by a community, unlike other languages. I mean, yeah, lots of languages built by communities, but Python in particular is one of, so the more popular languages that is really just community run and funded.
You might say it as something like it's built by a very diverse community, technically speaking, as opposed to say JavaScript, which is almost always web, and then kind of recently it's been a little Node, but like, it's astrophysicists, it's embedded, it's data science, it's web. Like, there's a lot of different pressures and areas that Python gets put into.
Yeah, and the focus has not been on performance. It's been on usability and features and keeping
backwards
it up to
compatibility.
Date.
Yeah.
I mean, it is an old language that has evolved a long way. Like, C is an old language, but C hasn't changed that much. C++ is an old language. Well, C++ has changed a lot, but it's got a very big community around it and lots of production. But Python is sort of, yeah, it's got such a sort of amazing and passionate community who do all this stuff for free. And performance is something that's sort of always been in the back of people's minds, but it needs a lot of work, and it kind of needs a stable Python language before you can consider performance. You can't optimize along the way of adding features. It's really hard. Anyway, this is sort of just say that it's a big topic, and lots of people have tried to make Python faster, and PyPy is an amazing piece of software that makes Python faster. And one of my first big Python projects, we used PyPy because it was really, really good and made things a lot faster, like 10 times faster. And we didn't have any sort of extension modules that didn't work with PyPy. They all did work with PyPy, and it was really, really good. So use that if it works for you. Although PyPy, it's a bit big though, but what it does really well. On the other hand, making CPython faster, just the core CPython, I think is a fantastic goal. And I think probably the thing I would say is that any interest in Python is good for CircuitPython and MicroPython and the general Python ecosystem, just because it's people working on Python and trying to make it better. Whether or not, there's something that comes out at the end is kind of secondary. It's that people are interested and hacking on things and having fun, and things will come out of it. Maybe it's not going to be a super fast CPython at the end, although that would be really great, and that's what people are really, really working towards now. But I just think the general interest in Python is the biggest thing that will come to us. Is that Python will be in the headlines more, and people will be talking about how it's faster now and it's interesting and it will change people's perceptions, and then people will learn more about MicroPython and through Python and C.
We'll start having to deal with all these articles. People are leaving C and Go because it's so slow now, and in fact, they had nowhere to Python.
Well, yeah, Python's such an ergonomic language. It's so
it's so lovely. I think actually the performance side is just so many layers, right? Like it's slow, except for if you use the SciPy libraries, all of a sudden then it's really fast, and then it's super interesting. Scott, go ahead, David.
No, I mean, it really depends what you're using it for. And I don't think you should, slow Python shouldn't be, it should be banished, sort of that concept. It should be like, use Python and see if it works for you. And if it doesn't, then use a different language. But that's the same you say with any language. It's like, use a language if it's going to work for you.
And oftentimes it's just, you're not using the right part of the Python ecosystem to address that problem.
Right? Yeah.
Scott, do you want to maybe weigh in on that real quick before we wrap it up? Since we're about out of time.
Generally I delegate to Damien. Damien does a lot of work on this core and makes it really fast. I try not to get sucked into the performance stuff because I'm trying to do the workflow side of things. But I did want to point out for those folks that are coming from CPython and may not have done embedded Python, is that the boards that we run on, both MicroPython and CircuitPython, we're very much in Moore's Law territory still. The first board that I supported is 48 megahertz, but the Teensy 4 runs at 600 megahertz. So we can get a lot of speed within this domain by paying a few dollars more. And that's important to realize is that like the things that we do for speed may not be the things that you would do in CPython.
Interesting. Yeah, there's hardly a make the computer faster answer.
Yeah, but we do have a turbo. We do kind of have a turbo button if we can just clock the CPU faster.
Yeah, awesome. My Pentium 90 had a turbo button. I left it,
and it was probably just as fast as what we're running MicroPython and CircuitPython on now.
How interesting! Yeah, for sure. All right, you guys. Well, we could go on and on and on about this, and maybe we'll have to do another episode. But I think we're probably out of time, so I'm going to ask you a couple of wrap-up questions. I normally ask the editor and PyPI library. Maybe we'll go ahead and do that, but I want to throw in maybe one more thing as well. So let's do editor first. If you're going to write some code that runs on either Circuit or MicroPython devices, what editor do you use?
Vim. I use Vim since day one, I think.
Right on. Scott?
I use Sublime Text.
Cool. Very good. Very good. Notable PyPI package, something out there that's pretty cool. I've seen a bunch of things going by in the live chat as we're talking. It's very active today. So
I think HTTPIE is really quite a cool tool for like instead of wget. It's very.
I've 100% moved to HTTP, I guess is how. Yeah, it's like curl or wget, but you get like syntax highlighting for your response. It's beautiful.
And it's actually a good tool for when you're like working with MicroPython. If MicroPython actually accepts, HTTP, it's not just a sort of pretty printing. It's good for actual workflow as well.
Yeah, cool. Scott, you got one to recommend?
For the folks in CPython who are getting into hardware, if you have a Raspberry Pi, Blinka is great.
Blinka, okay.
As the foundation, you'll want to find a device that you're interested in using, and then you can use Blinka. Yeah, I don't know. That's a really good one. The HTTPy is a good one. I'll have to take a look at that.
Yeah, I've completely switched on all my servers and even on my desktop to just have that for testing thing. It's really, really good. Okay, here's the extra third question that normally we don't get. So if you're going to work on a project, I have all these ideas of things that I would love to create and stuff, but I don't ever know really what the right hardware for it is. So I guess, Damon, you first. If you're going to work on something, you've got some idea, what kind of board would you get? Maybe you have to give us a little background, like the scope of the idea, the context. But what board would you play with if people are thinking of getting into stuff and playing with it and so on?
Yeah, that's a good question. It really depends on the project. If you want something like the Pi board, we started making and selling that like 8 years ago. That was with the first Kickstarter, and we still sell a lot of these. The original Pi board, down a little bit on that page. Yeah, that one. And that's just a really good general purpose workhorse with good I/O support, and I use it still today to do things. And that's really cool. If you want high performance Wi-Fi Bluetooth, if you just scroll back up a bit, then the new Pi board D is what you need. That has really fast Wi-Fi and really good Bluetooth support. The Raspberry Pi Pico, I think, is another really good option if you want something that has is relatively cheap and has good functionality, and this new PIO, programmable I/O stuff that Scott was talking about. That's also a really cool option. There's a whole lot of stuff out there. There's a lot of choice, and it's all really good choice.
Exciting. Yeah, very exciting. And not super expensive, as you all were saying. Like, you can get them and try them. It's not a huge investment. Scott, what's your dream board that you would, or recommended board you would start with?
I don't think there's any one board. I see some people trying to make a particular board they have do something that it doesn't necessarily do very well. So what I recommend people is actually go to learn.adafruit.com, which is where Adafruit has all of our tutorials. And look there, find a project that is close or exactly what you want to do, and then you'll see all of the stuff that you need to do that. That's where I would start, because not only are you picking the hardware that you could use to do what you want, but you're also getting all the software to do it as well. So you're definitely getting a head start by starting from an existing project.
Yeah, that's an interesting perspective. Like, instead of what board do I want, like what thing do I want to create and solve? Now, what hardware do I need to like facilitate that?
Yeah, and then the other thing you can do is if you go to circuitpython.org/downloads, you actually can type different features. Like, you want to see all the BLE boards or the Wi-Fi boards. It will filter out the boards there for you. And those are all the boards that CircuitPython runs on.
Very neat. Very neat. All right, you guys. Well, thank you for being here and sharing this. It's really cool to see the two projects working more closely together. And I hope they both keep going strong.
Thank you. Thanks for having me.
Yeah.
Yeah, thanks for having us.
You bet. So, final call to action. People want to get started. One from each of you, I guess. Like, what would you tell people?
Well, go to micropython.org, go to forum.micropython.org, where our forum is. That's sort of the most active place for discussion. And then GitHub MicroPython/MicroPython is also where all of the development action is.
Right on. Scott?
For CircuitPython, you can go to circuitpython.org, and the /downloads is particularly useful if you happen to have a device already in hand. That will get you the file for that particular device. If you want to hang out with us that are working on CircuitPython, we do have an Adafruit Discord server that everybody is welcome to join. You can go to the URL adafru.it/discord. That's the short link for it. And that will get you in there. You'll see there's a CircuitPython dev channel. That's where we coordinate all the development. And on GitHub, we're github.com/adafruit/CircuitPython. Although we are...
Sorry, go ahead.
I was going to say, we're moving more and more we have a CircuitPython organization as well. So maybe at some point we'll be github.com/CircuitPython/CircuitPython.
Right on. I was also just going to throw out that you do a fair number of live stream Twitch-like things. Maybe just tell people about that as well if they want to catch you there.
Yeah, so I started live streaming kind of like as the pandemic ramped up. as just like something I've wanted to do. So I started doing it regularly. I do it at 2 p.m. Pacific on the Adafruit channels. So you can go to youtube.com/Adafruit. It's called Deep Dive with Scott. There's a playlist there. They tend to be about 2 hours or more and very casual, no editing. But I answer questions and show off into the weeds of CircuitPython stuff. And we've gotten a lot of contributors out of that, which has been great. So if you want to hang out on a Friday afternoon, everybody's welcome to do that. And we've talked to Damien about joining that at some point as well.
Cool. Well, I'll look forward to seeing you both over there as well. So thanks for being on the show.
Thanks, Michael.
Thank you.
Yeah, you bet. Thanks everyone for all the comments in the live stream. See you later.